I'm controlling it. So basically, this thing measuring temperature of the wine or the must or the cap, wherever you put it, will control the flow. And this is a simple temperature control system. All right, so this little tank is designed for UC Davis. You fill it only to about this height, as opposed to that tank which needs a forklift. This tank is on a nice convenient little dolly so you can move it around. It weighs about 200 pounds when you got it full. It has better welding, electropoly stainless steel. But here's the jacket that has the cold water in it. And Davis has 152 of these, so they do several hundred experiments every season. They use this fermenter several times. Now, to control the jacket, we did a PSOC project, and we made this box, which I'll explain in a minute. But the way it works is this is my distribution system for both cold and warm water. And the cold water comes in this bottom pipe here from a little chiller I have outside, and comes in the bottom right here, which is directly connected now. Goes through the tank, goes around the back of the tank, comes out here, goes through this tube, and goes back to the chiller, so the chiller keeps the water cold. We run the water at about 4 degrees centigrade in order to keep the tank at 10. So what you do is every time the tank gets above 10, you squirt a little water in and cool it back down again. So you need a temperature control system. What we had to do was invent a box that would measure the tank temperature and then turn on the valve or not and control the temperature of this fermenter. The name of the game is how do you control water given a temperature with a battery-powered box. And the answer is, of course, since I'm Cypress's CEO, the answer is PSOC. It was a nice project for us to work this a waterproof box. So it's battery-powered, and you notice the board, there's one PSOC chip, and there's nothing else on the board. There's a little power transistor there, and that's it. So the thing is designed completely to run with a single PSOC, so it's a nice little project for temperature control. We have much more sophisticated temperature controllers I'll talk about in a minute. Okay, so how does it work? Let me start here. There are modes. For example, this says I'm in the cold soak mode. Now I'm going to go scroll through the menu, and I'm going to show you something. It says manual mode, then I'm going to set the manual mode. Now I'm in the manual mode. The temperature is 13.4 degrees centigrade. Now let me show you what this thing does. And this is a normal garden hose, so you could control a huge amount of water. This is a special valve. Most valves, when you turn them on like a lawn sprinkler, they require 1 watt, 200 milliamperes of 5 volts to hold them on, and as soon as you turn off the power, they shut off with a spring. This valve is a valve that only requires energy when you change it. So when you turn it on, a magnet holds it in the on state and leaves it there, and then when you turn it off, you overpower the magnet with current and you turn it off. Therefore, you can have batteries last for an entire year, even though they're driving a fairly crude electromechanical device. All right, now the question is, how do you control the thing with temperature? So now I'm going to go to the menu and I'm going to change the mode. There are 7 modes on here, only 2 of which I'll explain. And I'm going to the mode that says cold soak, and we have a set point of 24 degrees centigrade. So I'm going to set the set point, and I'm going to set the set point at 24 degrees centigrade. And now this thing is in a mode where the thermistor controls the valve. So this thermistor is currently at 12. This thing is set at 24, so it's colder than the set point, therefore it doesn't care. However, if I heat it up hotter, I'm controlling it. So basically, this thing measuring temperature of the wine or the must or the cap, wherever you put it, will control the flow. And this is a simple temperature control system. One chip is very cheap. As a matter of fact, the box costs 3 times more than all the electronics inside of it.